In this video, we're going to be looking at the common graphs that you need to be aware of, and you need to be able to recognize them just by their shape. Okay, so if I put some axes on here, and we're just going to work on these, then the first one that we need to be aware of is just the straight line graph. Okay, so if you see something like this, or kind of that, or down, or vertical, are you able to have a rough guess at what each of those equations would be? Especially this diagonal, y equals x, because everything is based around this. We might make it steeper or shallower, or we might do a horizontal or a vertical, but they're based on that y equals x linear graph. The next one is this x squared graph that looks like this. Okay, this is y equals x squared, and it could be down this way, left, right, up, down. But if you see something like this, you should be able to say that's a quadratic, that's an x squared graph of some sort. Okay, it may be flipped upside down, like this way. When you flip a graph upside down, it becomes its negative. So this is minus x squared. Okay, so this is y equals x squared. Then we have x cubed, which looks a little bit like an S shape, like this. This is x cubed. This is minus x cubed going downwards. Sometimes they look a bit like this as well. This is still an x cubed graph. It won't be y equals x cubed. It'll be x cubed plus 2x squared or something like that. But the thing that you're looking for is the basic shape. X cubed is kind of like a S shape graph. Okay, next one we need is 1 over x, which kind of looks, oh, that was bad ending there. It gets closer and closer and closer to the axes, but it never touches. Okay, so it's getting closer to the y and closer to the x, and the same down here. Okay, so it's kind of like these two slopes, like that. Okay, this is 1 over x. Y equals 1 over x. So this is its common shape, and then minus 1 over x would kind of be the opposite, flipped upside down. So it's a reflection in this x-axis. So we need that one. Let's get rid of all of these. And 1 over x squared is very similar, but they're both up here, like that. So that's 1 over x squared, and the reverse would be underneath, minus 1 over x squared. Okay, sometimes the square root of x appears, which is kind of like a quadratic on its side. 1 over x and minus 1 over x would be down here. They don't often do this one because there's some tricky bits about functions and one-to-one and all of this. So we don't see this one very often, but 1 over x is kind of like a quadratic on its side. And we also have the 3 trig graphs. Okay, sine, cos, and tan. So with this, we only need to know between 0 and 360, but we should be aware that this kind of continues forever in both directions. Okay, sine x starts at 0, and then every 90 degrees we kind of have to be aware of these major points. Okay, so 0, 90, 1 at its maximum, then back down to 0, minus 1 down here, and then back up to 0 again. So it's kind of like fluctuating like a wave that you might have seen this in physics. With cos, it's almost exactly the same, but it's kind of like you pick it up and drag it to here kind of thing. So it's just been shifted along a little bit. We start at 1, 0, minus 1, 0, and back up to 1 again. So sine and cos are very similar to each other. Okay, if you've learnt one, you've almost learnt the second one, but you have to be able to recognize the difference. And then tan, we don't often see tan, again, because this is a bit strange. It kind of goes from here and goes up, and then you'll see this sort of dotted line at 90 degrees. And you may, if you've learnt your trig values, tan 90 doesn't exist, or it's undefined, because this graph is approaching this 90 degrees, but it never touches. So it's getting bigger and bigger and bigger, but it never actually reaches 90. These dashed lines on a graph are called asymptotes, where a curve approaches but never actually touches. And then we have the sort of reverse here, 180, back up again. This is 270 again. There's another asymptote, passes through 0 at 180, and then it repeats and ends up at 360 like this. Okay, so this is tan x. Y equals tan x here. Not a very common one because of these difficulties, but you should also still be aware of it, how it looks, and the sort of features of these. Okay, so if any of those graphs were unfamiliar to you, put them on a flashcard. On the front of it, put y equals sine x, and then on the back, draw the graph, and then try to visualize when you're looking at the front of the flashcard, these features 1, 0, -1 like that. See if you can kind of visualize this picture in your mind with some numbers, and then you can use your calculator in the table function to actually plot these. If you're ever unsure, you can use the table function. I've done a video on this, on how to draw these graphs. If you're not too sure, have a look on my YouTube channel on the calculator, how to use your calculator video, and you'll see that the calculator will give you these numbers, and so you can actually use it to draw your very, very tricky graphs.